In this video we're looking at sine, cosine and tangent ratios. Let's draw a right angle triangle to see what we're talking about. So in a right angle triangle, the longest side, the one across or opposite the right angle, is always called the hypotenuse. And if we label an angle, suppose I call this one B, this one across from B is called opposite to B. And the other side that's not the hypotenuse touching against B, that's called adjacent to B. And these labels are important. So sine, cosine and tangent follow the rules SOHCAHTOA. This is an easy way maybe of remembering them. SOHCAHTOA. What this stands for is that sine of an angle, in this case B, is equal to opposite divided by the hypotenuse. Cos the angle B is equal to adjacent divided by hypotenuse. And finally, tan of the angle B, given by TOA, is opposite divided by adjacent. And these three formulas must be learned by heart. So let's look at some examples now. In the first one, it's actually not the easiest example, but we know what tan B is, and we want to find sine B and cos B. Well, we'll write down our rule SOHCAHTOA, because we're using sine, cos and tan, and we'll draw a triangle. Now, let's just draw a right angle triangle, and we'll label one of the angles B. Now the opposite side is an adjacent side, and there's a hypotenuse, so it's a good idea to label the triangle. Now we know what tan is. Tan is root 5 over 2, but tan stands for opposite over adjacent. So opposite over adjacent is root 5 over 2, so the opposite is root 5, and the adjacent is 2. They're in this proportion or ratio. Now to find cos and sine, we would need to have the hypotenuse as well. But since we know two sides, we could use Pythagoras' theorem to find this out. So that says that a squared equals b squared plus c squared, where a stands for the hypotenuse. X squared is equal to 2 squared plus the square root of 5 squared. So x squared is equal to 2 squared is 4, and root 5 squared is just 5, and 4 plus 5 is 9. So x is the square root of 9, or 3. Now we're almost there now. We could write this number 3 in on our triangle if we wanted at this stage. So what is sine B? Well, sine B is opposite over hypotenuse, so compared to B, that's root 5 over 3. That's it, and we don't have to do anything else with it. And cos B is adjacent over hypotenuse, so in this case, it's 2 over 3. And we just leave it like this as a fraction. Okay, example 2. We're given some triangles, and just can you write down the ratios of sine, cos, and tan of the angle marked. So we start off by writing down SOHCAHTOA, because these are our rules. This is just practicing what we did last time. So we start off, we'd label our sides. Maybe so compared to A, this is our opposite. So after labeling the sides, we could label them we'll do all the labeling here at the start. So compared to B, we have our opposite, adjacent, hypotenuse. Compared to C, we have our opposite, or adjacent, and the hypotenuse is always the long side. Okay, so let's fill this in. Sine of the angle A is opposite over hypotenuse, which is 3 over 5. cos of the angle A, well, that's K adjacent over hypotenuse, which is 4 over 5. And tan of the angle A, that's opposite over adjacent, 3 over 4. In a second example, sine of B, opposite over hypotenuse, is 5 over 13. Cos of the angle B, adjacent over hypotenuse, 12 over 13. And lastly, tan of angle B is opposite over adjacent, which is 5 over 12. So once everything is labelled, this is a very straightforward question. The last one, angle C, sine of C is opposite over hypotenuse, root 3 over 2. We don't have to do anything else with it, just leave it like that. Cos of the angle C is adjacent over hypotenuse, which is a half. And lastly, tan of the angle C is opposite over adjacent, which is, in this case, root 3 over 1. Now there's no need to write over 1, you could just write it as root 3 if you wanted. Make more sense. Okay, example 3. We're given a triangle, just can you write down the value of sine A, cos A and tan A, but see, first we're missing one of the sides, so let's use Pythagoras' theorem on this. Pythagoras' theorem is a squared is equal to b squared plus c squared, so the hypotenuse squared is equal to 15 squared plus the other side is called x squared. We take out our calculator here, and we have 289 is equal to 225 plus x squared, and if we take 225 from each side, we have x squared is equal to 289 minus 225. That's 64, and that's a nice one. The square root of 64 is x, and the square root of 64 is equal to 8. So x is equal to 8. We could mark this off then if we wanted onto our triangle. And now we can get our ratios. It's good to label our sides. Compared to angle A, we have our opposite is 8, our adjacent is 15, and hypotenuse is 17. So we write down our rules. So katoa. So sine of the angle A is opposite over hypotenuse, in this case 8 over 17. Cos of the angle A is adjacent over hypotenuse, 15 over 17. And tan of the angle A is equal to opposite over adjacent, which is 8 over 15. And that's the end of this question. Okay, example 4. It tells us here we want to draw a triangle that looks like this, where we know cos B. So we'll draw any right angle triangle. It doesn't have to be to scale. It's just a sketch. We'll call it out one of the angles B. We can label the sides compared to B. This would be the opposite side, the adjacent side, and we have our hypotenuse. Now we know that cos is K. I'll write down so katoa here. So we know that 5 over 13 is the adjacent over hypotenuse. So if we let the adjacent be 5, the hypotenuse be 13, we have the ratio. Well, we could use this information to work out the opposite side of x. So Pythagoras' theorem, a squared is equal to b squared plus c squared. That's the hypotenuse squared, 13 squared, would be equal to x squared plus 5 squared. So 169 is equal to x squared plus 25. Now we'll take 25 from both sides, so x squared is 169 minus 25, which is 144. Now this is a nice one because the square root of 144 is 12. So x is equal to 12. We could mark this off then on our triangle as well. So now that we have our three sides, our ratio question becomes straightforward. So sine of the angle B is opposite over hypotenuse, 12 over 13. And it asks us for tan of the angle B, which is opposite over adjacent, or 12 over 5. Thank you.